gonna learn how to use the properties of logarithms to expand an algebraic expression of logarithms. So remember, first thing we have to know is what expanding means. Expanding means that if I give you an algebraic expression, we want to obtain in result a set of additions or subtractions of logarithms where the arguments are isolated variables. That is, that we cannot have powers or coefficients or something weird looking inside my argument, okay? So let's start with a couple of easy examples. The first one is you have to notice that the argument of this logarithm is it has a power of 6. Because I don't want powers inside my logarithm, I need to apply a property. The property that can help us is the quotient property that we have here, that it says that if my argument has an exponent, that exponent can be rewritten as a number multiplying my logarithm. So this expression can be expanded as 6 times logarithm base 10 of x. This cannot be any, this is expanded already because our argument is isolated, it doesn't have powers or fractions or products inside. So this logarithm is expanded. Next example, I have a quotient here. And remember, if I have a quotient, a product, or a power inside my argument, I have to use these properties to remove it. So what happens with my quotient? This can be re-expressed as the subtraction of the logarithm of the numerator minus the logarithm of the denominator. So I can rewrite this logarithm as logarithm base 10 of x minus logarithm base 10 of y. This way, the arguments don't have any products, divisions, or powers. So this expansion is completed. Example 4. My argument has a power of 2. So again, I have to use the power property. That way, I can rewrite this as 2 logarithm base 10 of x. In this way, my argument doesn't have any power, products, or quotients, so this logarithm is expanded. In this example, I have a product inside my logarithm, meaning I can use the product property that tells me that if I have a product of the argument, in the argument, I can separate it as the addition of the logarithms of each argument. So this can be rewritten as a logarithm base 10 of the first argument plus the logarithm base 10 of the second argument. This way, our arguments are isolated. Bueno, our arguments don't have quotients or powers, so that is expanded. Let's see more complicated examples. For example, 5. Notice I have a bunch of properties or operations being applied to the argument of my function. The first thing I have to notice is that I have a power, then I have a quotient, and then I have a power again. So we're going to solve this by using the hierarchy of operations, meaning powers, quotients, etc. So the first thing I have to get rid of is of this power. So when I have a power inside my argument, that power is going to go outside as 2 times logarithm base 9 of u over v to the power of 3. Now, my argument is a quotient, so I have to use the property of quotients. So I'm going to separate this as 2 times logarithm base 9 of u minus logarithm base 9 of v to the power of 3. Notice that because these two affects this entire logarithm, that means that if I expand this logarithm into a subtraction, the 2 is going to affect both terms. So careful with parentheses. Lastly, inside here, I notice that this argument has a power, so I have to finish my simplification. So this is 2 times the logarithm base 9 of u minus, I'm going to plug the exponent outside as a number multiplying my logarithm, base 9 of b. Now, all my arguments are without powers, products, or quotients, so I can just finish my simplification by applying my distributive property, because this 2 is affecting both terms. So this is 2 logarithm base 9 of u minus 6 logarithm base 9 of b. Why 6? Because this is 2 times the already existing minus 3. And that's the end. For exercise 6, notice that the first thing we have is that we have a product, this product inside my argument. That is the first thing you have to realize. The first thing is a product inside. So by using the product property, I'm going to rewrite this as logarithm base 9 of z plus logarithm base 9 of the square root of x times y. And I'm going to rewrite from now on my square root as 1/2, because you know how to rewrite radicals as fractionary exponents. From here, this argument is already ready because it doesn't have products, quotients, or powers, but this one has a power. So I'm going to apply the power property to get rid of that exponent and put it as a number multiplying my logarithm. So this is logarithm base 9 of z plus 1/2 logarithm base 9 of x times y. Now, notice that again, this logarithm is already ready, but here I have a product inside my argument that if I want to expand, I know that I have to apply this property, the product property. So I'm going to apply it. And notice, because this 1/2 is affecting this logarithm, it's also going to affect the entire expansion of that logarithm. So this is logarithm base 9 of x plus logarithm base 9 of y. So if we finish rewriting this, this is logarithm base 9 of z plus 1/2 logarithm base 9 of x plus 1/2 logarithm base 9 of y. And that's it. Notice that the expansions don't have any parentheses, just the parentheses of the argument that is expanding, okay? Next exercise. In this exercise, again, notice the first thing you have is two things that are multiplying each other. So I'm going to apply the product property to expand it. So this is logarithm base 7 of z to the power of 6 plus logarithm base 7 of x to the power of 1/3. Why 1/3? Because you know that a radical can be rewritten as a fractional exponent. From here, you have that the argument of this first piece and the argument of this second piece have powers. So we are going to use the power property to get rid of that exponent. So this can be rewritten as 6 times logarithm base 7 of z plus 1/3 logarithm base 7 of x. And that's it. Your argument doesn't have any product or exponents or base, and your expression doesn't have any argument, any parentheses. This was a plus. Perfect. Exercise number 8. In this exercise, again, my argument is raised to a power. So the first thing you have to get rid of is the power. So this is 5 logarithm base 6 of x to the power of 5 over y. Next, you have a quotient, so you use the quotient property. So this is 5 times logarithm base 6 of x to the power of 5 minus logarithm base 6 to the power of 6. of y. Remember, because this 5 is affecting this logarithm, if you expand or rewrite this logarithm as an expansion, the 5 is affecting both terms, okay? From here, I have this logarithm where its argument still has a power. So let's apply again the power property to remove it. So this is 5 times. I'm gonna pull down this exponent. Rewrite the last one as usual. And then the only thing I have to do is to finish my expansion. That is to get rid of parentheses. This 5 affects this term and this term. So if I apply the distributive property, this is 25 logarithm base 6 of x minus 5 logarithm base 6 of y. Next bunch of exercises. In this exercise, we have a bunch of products. Notice you have the product of C times A times B. So this can be expanded as a sum of logarithms. So this can be written as the logarithm of C plus the logarithm of A squared plus the logarithm of B cubed. And because these arguments have a power, we can use the power property to pull that exponent outside. So this is logarithm base 7 of C plus 2 logarithm base 7 of A plus 3 logarithm base 7 of B. And this is your expanded expression, and there's nothing left to do. In this exercise, notice that the first thing you have is something raised to the power of 3. So you have to pull that exponent down. So this is 3 times logarithm base 3 of set times x to the power of 5 over y. Now, in this logarithm, we have a quotient, so we have to apply the quotient property. So this results in 3 times logarithm base 3 of the numerator minus the logarithm of the denominator. Remember, because you expanded this logarithm, this 3 affects the entire expansion. That's why this 3 is multiplying the entire expansion. Now, my first logarithm has another power, so I have to expand it. This is 3 times 5 logarithm base 3 of x times y minus logarithm base 3 of y. And again, the first component has a product inside its argument, so I have to expand it once more. Notice that this 5 is affecting this logarithm, so it's going to affect the expansion of said logarithm. So this is 5 times logarithm base 3 of x plus logarithm base 3 of y. I close this parenthesis because this 5 only affects this expansion minus, this was a set, and this was a set, minus logarithm base 3 of y. So if I just apply the distributive properties, this is 3 times 15, 3 times 5, this is 15, logarithm base 3 of x plus 15 logarithm base 3 of set. 3 times this one is minus 3 logarithm base 3 of y. And that's it.